Okay, we'll start section 9.4 now, which is all about multiplying and dividing radical expressions. From earlier, remember that if you have two radicals that have the same index and you're multiplying or dividing them, you can combine those to a single radical. Okay, now you can't do that if you're adding or subtracting, but we've done quite a bit of this already, multiplying and dividing radicals. So we're just going to continue doing that, I guess, in this section, but there's going to be a lot of simplifying, though, along with that. So we're going to simplify and assume that all the variables represent non-negative numbers in problem 21. Okay, part A, 5 times the square root of 6 times 4 times the square root of 3. Well, I know that 5 times 4 is 20. The square root of 6 and the square root of 3, neither one of those simplify to be whole number values, but if I multiply them, I would get the square root of 6 times 3 is 18. Okay, now root 18 is going to break down for us. I don't want to use 6 and 3, right, because neither one of those radicals go away, so I need to think of the best pair of numbers in order to break this down further. If we use 9 and 2, I know the square root of 9 is 3. Root 2 would be the leftover, so 3 root 2 would be the simplified form of the square root of 18. 20 times 3 is 60, so 60 root 2 would be my answer then. Here's another one. Part B, the cubed root of 4 times the cubed root of 4. Well, the cubed root of 4 is not a whole number value, right? But I can multiply, I can get a single radical out of this by multiplying the inner terms. 4 times 4 is 16, right? And the cubed root of 16, well, that's still not a whole number value, but I can split this, and I know that 8 times 2 is 16, and I also know the cubed root of 8 is 2. The cubed root of 2 would be my leftover, so 2 times the cubed root of 2 would be the simplified form of the cubed root of 16. Okay, here's another one. The cubed root of 2 times the fourth root of 2. Well, I can't combine these to a single radical like I did in these other two problems because the index is different. You can only combine a radical if the index is the same on both of those. Okay, so I wouldn't want to look at the problem like I did the other two. But the cubed root of 2, that's the same as 2 to the 1/3. And the fourth root of 2, that's the same as 2 to the 1/4. Okay, if we rewrite that using rational exponents, then we can use that first law that was in the list of the laws of exponents in section 9.2 that said that you can keep the base and then add the powers together. Okay, so I've got a side calculation over here where I'm adding 1/3 and 1/4. I get 7/12 when I add those. 2 to the 7/12 would be my answer in rational exponent form. Typically, if we have a radical form to start, we'd want to give our answer using a radical form. Okay, so I'd want to rewrite this in using radical notation. It's going to be the 12th root of 2 to the 7th. Now, 2 to the 7th is 128. So the 12th root of 128, that would be my answer in simplified form. Part D, okay, we're multiplying again. Now here I've got the same index, right? So I can get a single radical by multiplying the inner terms. A to the 9th times A squared, keep the base and add the powers, that'd be A to the 11th. B to the 7th times B to the 5th is B to the 12th. And then I've got C to the 22nd there. Okay, now I'm going to split this into two radicals, not like what we saw here, okay, because neither one of these radicals goes away then. But the idea is that we'd want to separate this into things that we know the fourth root of and then the leftover. Okay, now in separating this, the powers of A, B, and C should be multiples of 4, since I've got a fourth root. 8, 12, and 20 are multiples of 4, right? So now A to the 11th, that's the same as A to the 8th times A cubed. A cubed would be my leftover. B to the 12, well, 12 is already a multiple of 4, so I'll just keep that term as is there in the first radical. c to the 22nd, that's the same as c to the 20th times c squared. Okay, now the things in this first radical I know the fourth root of. I've rewritten this so that I've got the fourth root of something raised to the fourth power. The index and the power of 4 can go away. And so I'm looking at a squared b cubed c to the fifth times the fourth root of a cubed c squared then as my answer. Problem 22 is some more simplifying. Assume that the variables represent non-negative numbers. Okay, we're going to be doing a lot of distributing and foiling when we simplify these problems here. But when we start in on that. Okay, so in part A, the natural thing to want to do is distribute the square root of 5 into these two terms. So that's what I've done. The square root of 5 times the square root of 10 would be the square root of 50 if you get a single radical out of that. The square root of 5 times the square root of 5 would be the square root of 25 if you get a single radical out of that. Now the square root of 25 is 5, so the radical goes away on the second term. The square root of 50 can be simplified. I know that 25 times 2 is 50, and I also know the square root of 25 is 5. So 5 times the square root of 2, that would be the simplified form of the square root of 50. 5 root 2 minus 5, that would be my answer. Okay, now of course I can't combine either of these, right? One term has a radical and one does not. So this is as simplified as I can get it. Okay, of course, like everything else that we've been doing, keep the answer in exact form. Okay, we were doing like nothing on the calculator for pretty much most of this entire chapter, in fact. By the way, just an observation here. The square root of 5 times the square root of 5 ends up being 5. In general, the square root of a number times the square root of the same number will give you that number that is the radicand. So like on this next problem here, if I have 3 root 2, which I'm going to distribute into these two terms, with the first 3 times 4 is 12. Root 2 times root 2 is 2, because the square root of 4 is 2. And that's what I was just describing up here. The square root of a number times the square root of that same number is always going to be that number that was the radicand. Root 2 times root 2 is 2. Root 5 times root 5 is 5. Root 13 times root 13 is 13, etc. Okay, now I finished distributing. 3 root 2 times root 3 would be 3 root 6 then. 12 times 2 is 24, and I can't do anything further to simplify this other term. 24 minus 3 root 6 then would be my answer. Okay, part C. Again, we're going to distribute. Okay, the cubed root of a times the cubed root of a, that'd be the cubed root of a squared. The cubed root of a times the cubed root of a squared would be the cubed root of a cubed. The cubed root of a cubed would be a, since the index and power match there, with those both being 3. The cubed root of a squared, I can't do anything more to simplify that, so at that point I'd be done. The cubed root of a squared minus a would be my answer. Part D, again, we're going to distribute. So the square root of x to the 9th y to the 6th times the square root of x cubed y to the 6th as a single radical would be the square root of, keep the base and add the powers, x to the 9th times x cubed, that'd be x to the 12th. Y to the 6th times y to the 6th is y to the 12th. Distribute this into the second term also. Okay, the square root of x to the 9th y to the 6th times the square root of x to the 8th y to the 7th. That'd be the square root of x to the 9th times x to the 8th is x to the 17th. Again, keep the base and add the powers. Y to the 6th times y to the 7th would be y to the 13th. Okay, now in this first radical, x to the 12th, that's the same as x to the 6th squared. Y to the 12th would be the same as y to the 6th squared. So if I have x to the 6th, y to the 6th, that whole thing squared, and I'm taking the square root of that, the square root sign and the power of 2 will go away, and that leaves me with x to the 6th, y to the 6th. Minus, now x to the 17th, that would be the same as x to the 16th times x. This x would be the leftover. Okay, the square root of x to the 16th would be x to the 8th, since x to the 16th is the same as x to the 8th squared. Y to the 13th, that would be the same as y to the 12th times y. This y would be my leftover, and the square root of y to the 12th would be y to the 6th, since y to the 12th would be the same as y to the 6th squared. At this point, I'd be done. I can't combine anything. Okay. Again, there's two terms here. One has a radical, this one here, and the other one does not. Sometimes I see students make the mistake that like they get the right answer, but then I don't know, they try to oversimplify or something like that, and they want to combine everything to one term or something like that. Don't do that. You can only combine things if they're like terms. Okay, like for all of these, we've got two terms, and there's nothing more that we can do to simplify that. So be sure that you know when you're done with the problem. Of course. All right, here's another one, part E. Now the natural thing to want to do here is to FOIL this out. Okay, so if I take the first terms, 2 root 3 times 3 root 3, 2 times 3 is 6. Root 3 times root 3 would be 3, right? Or the square root of 9 is 3. Okay, then the outer terms, we're looking at 2 root 3 times negative 2 root 5. Positive times negative is negative. 2 times 2 is 4. The square root of 3 times the square root of 5 is the square root of 15. And then the inner terms, root 5 times 3 root 3, that'd be 3 root 15. The last terms, root 5 times negative 2 root 5, positive times negative is negative. That'd be the same as, I'd be getting a minus 2 times the square root of 25 is 5, right? Root 5 times root 5 is 5. Okay, so then combine the like terms here. 6 times 3 is 18. 2 times 5 is 10. 18 minus 10 is 8. And then the middle terms here are like terms with radicals. Negative 4 root 15 plus 3 root 15 would be minus 1 root 15. So 8 minus root 15 would be my answer then. Okay, part F. Here's, this would be another FOIL it out, right? The square root of 5 plus the square root of 6 squared means I've got the square root of 5 plus the square root of 6 times another square root of 5 plus the square root of 6. Don't make the mistake that some students would, and they'd want to bring in that power of 2, and they'd say 5 plus 6 is 11. Okay, I'll see students sometimes do that. Of course, you can't bring in an exponent unless you are only multiplying or dividing. Never ever if you're adding or subtracting. Okay, so I wouldn't want to just bring the exponent into these two terms and call it 5 plus 6 is 11. But I got to FOIL it out, like I said. So let's do that now. Root 5 times root 5 is 5. The outer and the inner terms, we got root 30 plus another root 30. That would be 2 root 30 in the middle. And then the last terms, root 6 times root 6 is 6. Okay, combine your like terms. 5 plus 6 is 11. Can't do anything with this one. 11 plus 2 root 30 then would be my answer. Okay. Part G. The square root of x plus the square root of y times the square root of x minus the square root of y. Well, I'd FOIL this out, right? The square root of x times the square root of x is x, right? The square root of a number times the square root of that same number is always that number that was the radicand. Now, the signs alternate here, so the middle term is going to go to 0, right? In the middle, I'm going to have negative the square root of xy plus the square root of xy, that'd be 0 in the middle. So go right to the last term. Positive times negative is negative, right? The square root of y times the square root of y is y. So I just get x minus y then as my answer there. Okay, now here'd be an application of that. Okay, in this problem, like x is 17, y is 23. The signs alternate. So this would still be a FOIL it out type deal, right? Root 17 times root 17 is 17. The middle term is going to go to 0. Positive times negative is negative. Square root of 23 times the square root of 23 is 23. And so I just get 17 minus 23 is negative 6. Okay, here's another one. FOIL it out. 5 root 2 times 5 root 2. Well, 5 times 5 is 25. Root 2 times root 2 is 2. The signs alternate here, so the middle term is going to go to 0. Go to the last term now. 2 times negative 2 is negative 4. Root 7 times root 7 is 7. So we end up getting, let's see, 50 minus 28 is 22 would be the answer there. Okay. By the way, just a terminology here. We call, in these last three calculations, the second expression is a conjugate of the first one. Okay, conjugate just simply means that you're going to switch the sign to its opposite there. Okay, so I've switched this plus sign to a minus sign. If I had, now of course the expressions have to be the same, it's just got to be a sign switch. So like these are not conjugates, okay, since these two expressions are not the same other than just a sign, okay. Anyway, the term conjugate is a term that we'll use for some other things. That's the only reason why I mention it. Okay, let's take a look at part J next. The square root of 200 over 5. Well, okay, I wouldn't want to. I guess I could handle this a couple of different ways. One option would be to split this into two radicals. I would have to simplify the square root of 200 though. And then I would want to cancel some things if they do cancel, okay? Maybe a better option would just be to start by taking 200 divided by 5 is 40. So, rather than working with a fractional form here, we just work with it simplifies. The square root of 40 is going to break down. If we use 4 and 10, that would be the best pair of numbers because we know the square root of 4 is 2. Root 10 would be the leftover. Root 10 doesn't break down further. So 2 root 10 would be my answer. Okay, here's another one. Now I mentioned that, another option that you could have taken is that you could have split this. You could have said the square root of 200 over the square root of 5. If you did that, you'd still get the same result, okay? Since 200 is the same as 40 times 5, and the square root of 5 would cancel with the square root of 5, so that would still leave you with the square root of 40. You're just handling the problem a little bit different. The answer would still be the same if everything was done correct. Anyway, that's what I'm doing here in this problem. I'm splitting the radical. Of course, I can't actually divide anything, right? Because I've got variable terms in here. Let's split the radical. Now the square root of 12 breaks down. 12 is the same as 4 times 3, and we know the square root of 4 is 2, so 2 root 3 would be the simplified form of root 12. The square root of x to the 4th, y to the 6th. Well, x to the 4th, that's the same as x squared squared. Y to the 6th, that's the same as y cubed squared. So both of these can be rewritten so that they are rewritten into a form of something squared. If we take x squared y cubed squared, then the radical and the power of 2 would cancel. That would just leave us with x squared y cubed in the denominator. Okay, and we'll stop the video here.